Welcome back. This is Professor Robert Needing, and this is Math 068. Tonight we're talking about Section 9, the confidence interval calculations through Bootstrap. So you want to have your access to StatKey available along with Section 9. So in Section 9, the first thing we start with is this is another thing or a piece of technology in order to implement your knowledge or your confidence skill with the confidence interval level. Remember the other night we talked about a confidence interval level, and we calculated one to where we took the statistic and we added or subtracted 2 standard errors. And that was the norm for any kind of work with inside of a confidence interval level. So what can we do with technology that will help us out in this particular situation? So the book tells us that, first of all, StatKey has a center area which deals with nothing but bootstrapping. And for this chapter, we're going to be dealing primarily right inside this area. So a couple of things that are going to get covered in this first area. And I'm going to go over them real quick, and then I'm going to go do them on the computer. It says we can load sample data in several ways. We can choose a data set from the textbook. I'll show you how to do that. And then we can create a bootstrap distribution for a mean, a median, a standard deviation, any of the following things that are built in for that data set. All of these are pre-built data sets, and those data sets are in under every one of the different kinds of bootstraps that you can run. You can also do a quantitative upload, or you can do a categorical data change, and you can change your own data. So right now I'm going to jump off to the side. We're going to go do all those things. So one, from StatKey, we're working here in the center. And so let's just say that we're doing a single mean. And let's say that what I'm running is some preloaded data set. Right now, Mustang prices are in here, and you can see them right down here, Mustang prices. And this data right here is the original data for the Mustang prices. If I want to see that original data, I can simply just go into the top and I can edit the data. I can see all the numbers that were preloaded, and I could change any one of them if I wanted to. It'll allow me to make a change in any one. So if I want to change this 3 to a 7, I can hit 7, and I can hit OK, and boom, that will be changed for me. Notice it now is a custom data set. And over here, the statistics changed slightly because of the 7 I created. If you want to actually change a data set to something else, maybe Atlanta commute time, notice that this sample over here will completely change. We now have 500 different measurements in here. And if we looked at that file of data, it's much, much larger than the last one because there's 500 things in this one. Now, I'm not limited to just a mean. I can also click a proportion. And in a proportion, I will have different data sets. And these are not the same data sets as the last data sets I had. And you can see that the data changes over the side to where now we have a count of a proportion. Well, if I click the edit data set now, I can actually see that I can change this fraction of, I'm going to change. This is 246 out of 500. Let's say that I want it to be 300 out of 500. If I hit the data set change and I hit 300 and I tab to the next, I hit 500, which would be the same as 3/5, I would get 0.6 for my data set proportion right now. And notice again, I'm in a custom data set. Third option I can do is I can go outside into the StatKey system. I can actually go find a data set that I want. I can download it as a CSV. So maybe I need cricket chirps. I want to pull that one in. I want to go back to StatKey. I want to go to, I'll use single mean. I want to upload a data set, and I want to pick my cricket chirps. From there, I have to pick one of these to be my data set. I'll go with chirps because I did single mean. And now my data is 7 values with a mean of 133, a median of 123, and a standard deviation of 43.84. I can also do, in this editing of data, I can do a copy paste from Excel or Word or some other documentation if I need to. All right, so let's go back and let's see what other fun they have available for us. So I showed you all the way up through here. Now we're going to talk about actually generating a bootstrap distribution. So we're going to go back to the confidence interval for a mean Mustang price. And what it says to do is generate 1,000 samples. Now, when we generate 1,000 samples, it's going over here to the sampling, and it's repeatedly pulling bootstrap samples like we discussed the other night. So a bootstrap sample is a sample of same size from the original area. This is the original sample. So it goes in here and it's going to reach in, it's going to pull out 25 samples and it's going to average them and plot them. And it's going to do it again. It's going to throw them all back in, get 25 new ones, boom, get an average and put it over to here. I'll show you that. So I go stack key, I go to single mean. I'm in Mustang already. You can see here's my original 25 that we discussed already. I'm going to hit generate one sample just for this discussion. Here are the 25 that it reached in and got. And when it reached in and got 25 and it took all of this, it took these values, it got a mean of 18.868 and it plotted it right there. If I did it one more time, it put it all back in and it got a mean of 15.6 and it plotted it right there. And if I did it one more time, it got a 16.52 and it plotted it right there. This is the mean of these three different bootstraps. So when I hit generate 1000, it happens 1000 times super quickly. And after it's in there 1000 times, it finds its own center of 16.06. For all 1000 and actually 3 of these dots, because remember I ran it 3 extra times, it tells me you did this 1003 times, you have a mean of 16.061, and your standard error is 2.189. To go one step further, if I click the two-tail design, I now get some new data that's present in front of me. So let's go back to our gridded work and let's talk about this for a second. When I generate that bootstrap and I click that two-tail for that CI, what's taking place is that the calculation of two standard errors is being multiplied plus and minus from my center in order to create ends or limitations of my interval. And that's the word we used in class the other day. My interval would progress from 12.056 to 20.652 on a 95% CI. All of these things that are being discussed here in these red boxes are things that I talked about on the previous slide for you. I'm going to go back to mine. So I did my 95%, and notice I got in my run 11.916 and 20.302. Now, if I reset the data and I go back to Mustang prices one more time and I generate 1000 and I run a two-tail design, you'll notice I don't get exactly the same numbers. I am super close. However, though, like I'll do it one more time. This is a 12 right now on the bottom. My bottom CI is 12.00. If I reset and rerun and I do my two-tail, I'm 11.83. It is not unusual. Matter of fact, it is common for the CIs to slightly change. That's why most of the time when we actually to run data and run problems, we tell you to run this sample here, this 1000 up to 10,000. So you hit the button 10 different times until you run that number up to 10,000, because 10,000 run is much more accurate. None of them are wrong. And notice what happened. I'm at 11.82, so I feel or 89. I'm very comfortable about that. And I'm also very comfortable at 20.63. These are the top and bottom of my CI for this data set. As I continue down through, it talks to you that that's exactly what that is, showing you the 95% CI. Now, it also says that you could change the CI to something else, like for instance, 90%. So if I would go back to my set and I said, I don't want this to be a 95.6, I want this to be a 90%. I just simply click on that and I change it to 90 cents. Now I have 12.548 and 19.7. I'm going to compare that to what they have. 12.056 and 20.652. So it's slightly different, and slightly means slightly. It's not very far off at all. And if we did the calculations, taking two standard errors up and down, we would find that we were also very close to those same two numbers. The deviation in here is not to be worried about. So this 90% confidence interval will become 12.566 to 19.860 on this data here. It says, notice it says, your results may vary slightly. Okay, so here's what they want us to do. They want us to modify the data for this. They want us, first of all, determine the sample statistic, which I have down, and then go through all the steps available and record those steps in order to create the CI. So first of all, it looks like we have a set of data where we have 9 out of 20 females who are dieting and 4 out of 15 males who are dieting. So what we want to do is we want to take those two proportions and we want to find their difference. Anytime you have two proportional statistics, you want to find the difference in them. And if we go down to letter B, it says clearly, list the statistics steps to construct a 90% confidence interval level to estimate the difference in the proportion of females and males in the population who are dieting. So we write that out as p hat of female minus p hat of male, and that's 9/20ths minus 4/15ths. If you take your calculator, that's 11/60ths, and if you divide 11 by 60, that's 0.183. I'm going to show you in StatKey how to actually enter those particular values right into StatKey and let StatKey do all of the lifting for us. So let's go back to StatKey, go back to the main, go back to difference in proportions, go to edit the data. The first fraction for us was 9 out of 20 females. We put 9 out of 20. The males were 4 out of 15. So we put 4 out of 15. We hit OK, and I like that StatKey does the work for me and turns this into 0.183. There's my difference in proportions. So when I look at StatKey, StatKey says that great, that's what I'm supposed to do. So StatKey, I click on the CI, I edited the data. Now what I'm going to do is I'm going to generate the CI. So I'm going to do the steps. We're going to click on the generate 1,000, and it's going to generate based on this statistic, the best point system that they have. I'm going to choose two-tail. I'm going to click on 95%, and I'm going to make it 90%. And then I'm going to look at my confidence interval levels that I have. I'm going to switch out. I'm going to generate 1,000. That's what it said to do. I'm going to click two-tail. I'm going to change the CI from 95% to 0.09. And in the bottom, I'm going to record my values of 0.83 and 4.33. Pretty close to what they were. As a matter of fact, I was dead on the bottom, and I was less than 1/1500ths off on the top. So the question is, what is the confidence interval level for this data set of the difference of females and males in population who are dieting? It's negative 0.83 to 0.417. Please use this information wisely. We'll be doing a lot of calculations in the CI, and StatKey can really help you with some of that difficult computations. See you on the next chapter 10 as we progress through the course, and we will be working in chapter 10 on probability basics.